All right, I want to show you some code I've been working on, which is based in my version of Mumps, which is available for free download. Mumps is, in my version, is both interpreted and compiled. And what I've done here is written a program that will read a Glade file and write code. Now, Glade files, as you may have seen from my other videos, there it is, there, mumps.glade, look like this. And what they are is layout files. And what you do is you go up here and, like, say, if I want a button, I drag it over here, and now I get a button hanging off the edge here, and then I put attributes and so forth to it. I don't want that button there. Get rid of it. I already got things in here. If you've seen the Glade material, you could probably recognize what we've got here. It's a layout. It's a nice graphical layout tool that you can lay out what your app is going to look like and how it's going to behave. So these are, it's got, some of these aren't fully fleshed out because it doesn't really open them all. But yeah, there they are. There are probably some more hiding underneath there. But what do we got? We got radio buttons, we got toggle buttons, we got check boxes, we got spin buttons, I guess they call them. Spin buttons, entry box, plain old button, text, a label, text view, our viewport, in a text view in a viewport. We can just, write out text and so forth. And down here we have a tree view, 3-column tree view, which is very handy in Mumps because Mumps uses a hierarchical database. It's got 3 columns. Now, in all of these, there's some other things up here like tree store, text buffer, and adjustment. They're used in adjunct to some of the things on the screen. The adjustment is used with the spin button. It holds the information as to what the present position is. Text buffer is the buffer for the for this text view, and tree store is the information or the for the actual tree, the hierarchical tree that will be built inside this window. They are kind of, well, we'll show you how I'll show you how you build them, but they are kind of built in. They're part of the scheme. All right, every one of these guys here, like the toggle example, has a name. You got to give them a name. You can pick the name. The names are free form, whatever you want. I don't believe they can have spaces in them. But yeah, you pick a name. There's only a couple of places where the names are restricted, and for every one of them, you pick you handle the signal. In this case, toggle one on, toggle one toggled. They got to have signals. What happens when you click the button, or do whatever you do, clicking something, dragging, clicking, whatever it is? There's a signal generated, and it's on toggle one toggled. And I did that in other videos. This is a standard way of doing a layout. This is a standard looking Glade GTK layout. Okay, and like I say, everybody's got to have a name. They've got their signals handlers and so forth. This doesn't have a signal handler. The signal handler for it is select. That's it there. The signal handler for the tree is select. There's other possibilities. That's the one I'm using. The only thing with the tree is a little different. There is restricted the naming. The columns have to be call 0, call 1, call 2. And the renderer has to be call 0R, call 1R, call 2R, because it's looking for names like that. All right, but otherwise you're free on naming things, and by name I mean the ID back here. All right. Okay. Oh yeah, I think that one has to also be. I don't know if that name is restricted. I think that's you can any name you want on that as well. But these guys here have to have a specific name because they're enumerated. All right, that's what it looks like. It's a standard Glade file. It's probably going to complain because I made a modification there. All right, this is a larger example file. It's got a bunch of stuff in it. This file here, apt-build.script, actually does a couple of things. It runs a program to read the Glade file and to generate other files for most GTK 1, 2, 3, and 4, and these guys down here, the on files. And then it compiles part of it using the Mumps compiler. Only parts of it are compiled. But anyway, so it does both those. So when I run that, I actually build my application from the Glade file. All right, so I'll just run it here. I've ran it a little while ago, so that's what it looks like. Okay, doesn't take long. There's some warnings. I'm going to ignore them. I'll get rid of them later. All right, so I built the application. Where's the application? It's right there, GTK. All right, so yeah, I'm going to run it, and I'll say GTK. It was there before, of course, but it built it again. and you get random messages that pop up. And there is the application actually up on the screen, and it looks a lot like the Glade file, not surprisingly. All right, so now it doesn't really do too much. It's mainly an example, but let's start clicking. Toggle example. You see in the background there, this is the window. This guy, if it wants to write to console, right, this is the console over here it's writing to. All right, so when I click toggle, you'll notice it says toggle one, that's the name of the button, toggled, and the routine that's actually handling it on toggle one toggled mumps. And you see the 01 indicating whether it's depressed, asserted or not asserted, okay? Active or not active is the actual internal terms. So what do you want to do when it's, well, that's in this routine is where you'd write the actual code to do something, as opposed to the code to set it up to get here so that you can do something. So all the superstructure code's been created. So if I click the radio button, radio 2, you notice you get two toggles there. Radio 1 toggled, radio 2 toggled. Well, there were two toggles. Radio 1 toggled off and radio 2 toggled on. If I hit this one, you'll see that radio 2 toggled and radio 3 toggled. It's a two toggle thing because they both toggle. One goes off, the other goes on. I click back here, you'll see again. Okay, so what do you want to do when the radio buttons are toggled? It's up to you. Check buttons. And it's saying 0 and 1, checked or not checked. This is... I'm not really using this. That you see as I type it, it's telling me what I've typed so far. I'll use that later if I get that far. All right, so that's it. And there's a text buffer up here, and when it loaded, it typed some stuff in. All right, and there you see the stuff that it typed. All right, one of the things it has is it has in here is a tree. There is something called the medical subject headings. It's developed by National Library of Medicine, and I'm required to give you a notice. This is the 2003 text. I'm too lazy to go out and get the more recent text, but I only use it for examples. That you are not to use this for clinical decision making. It's out of date. It's obsolete. I don't know why anyone would, but anyway, this is from National Library of Medicine. There's more recent ones. They're probably just bigger. So what does it look like? It's fairly big. It looks like this. They've sat down and figured out all the names in medicine and all the places and stuff, and they've given them code. So body regions, A01. Abdomen is a body region, A01.047. Abdominal cavity is a body region in the abdomen, and its number is 025. And we go on and on and on and on. It's a hierarchy, as you can see. The name comes first, and then the code comes second, and the code is a hierarchical code, as things tend to be in medicine. All right, so that's that guy. And I've got a program in here which loads it into the database. Load tree store. Now, it's going to take a moment because it's quite a large amount of it. It's actually, the GTK is kind of slow. There it is. And there's my body regions. Now, if I click on it, you can say... there's my abdomen, and if I click on the abdomen, I keep going down, and I didn't know there were so many parts, did you? I didn't know what their names were, but anyway, you can see there is the various parts of the in the abdominal cavity, and you know it's a tree. People that have used Mumps will of course know what I'm doing here is in the sense that Mumps organizes things as trees. And then we get the subject heading. And over here, in this column, it's just giving the terminal code, the last code in the thing, because that may be useful in and of itself. But anyway, so there is a tree. So up here, let's collapse everybody. All right, so this is a search function, A06 224. That's a subcode of it. And let me see, and hit find. And there it is, A06 224. And these are the subheadings under A06 224, which I don't know what they are. Doesn't matter. Okay, so that was a search operation. Now this is what you do in a Glade application, something like this. There's the find button there, and there's also a tabular version of this, which actually takes forever to load because it generates more lines, and they're all being generated in memory. It's way too big to be, in a tree store. You don't want to have everything in memory. It's probably better just to have a part of the tree in memory because it apparently doesn't store big, giant things all that efficiently. But nonetheless, this is, I think, a convincing. There it goes. You notice up here stuff was happening when I was clicking on these guys. It was you notice what I'm clicking on ended up there in the in this text view. 766. We go down to 766, 163. All right. So I'm just proving that when you do things, other things can happen. So it's kind of an application. Now, how does this all work? It generates files, as I said. It generates GTK1 through GTK4. It also generates these files here, the on files. For every signal that you establish, it'll generate one of these files. These files contain working code. For example, what was the one up here on the top? Toggle example. On toggle button toggle. Now, Mumps code is interpreted. Sometimes it can be compiled, but I'm using interpreted. So whatever's in here is going to be executed when you click on the button. It loads the little tiny file and executes it. It's pretty common Mumps procedure. It's not unusual. Mumps tends to have lots of little files, and you click on them, you bring them in, you execute them, and so on. Because this text, and this is what it looks like. They are going to have do up arrow gtk.4.h at the beginning. That just establishes linkage. It's already been written. But you can see this is Mumps. Right on toggle one there writes out the text that there, blank, and the value of widget. Widget is the pointer to the widget the reference really, to the widget that invoked us. It's pointer reference, I don't care. It's automatically supplied when you start a program, and it's a number that you could use for debugging to make sure everything's right. Exclamation point means new line. And then the second one down here, I have a built-in function. And the built-in function is z gtk toggle button get active. Now, if you look that up without the squiggles, without the $z or the squiggles, you'll find that's the name of a GTK function, which is GTK toggle button get active. And you provide to it the pointer to the toggle button in question. It will return you true or false, in this case 0 or 1. So and that's what it does. It writes out 0 or 1, and then there's the exclamation point at the end here, which it means a new line. So yeah, at this point here, when I toggled it, you can do whatever you want. Let's look at something else. Like one of them there was load. What is it here? Load tree store on load tree clicked. That's what I called it. Load tree clicked. And looks the same. Part of it's already written for you, the stub, the GTK4th, and it says, it's already been written. It says parts of this about it. Then there's parts I wrote. Okay, this part up to this point here, it wrote. Then I said, well, what do I want to do when I get this? Well, I want to say, first of all, clear out the tree store, and guess what? There's a function that clears it out and zeroes it. And then here we're into Mumps. Now I'm actually programming in Mumps, and I say the tree I want to load. The origin of the tree is at mesh with an index of 0, or mesh with no index. They both work the same. They're both in here. Only the second one obviously is passed down. And then I invoke another Mumps program. That's just a standard Mumps program at this point. There's no GTK in it. I guess there is GTK down there in that program, yeah. So let's bring that program. Load Mumps. It's down here. Yeah, there's the tree view version of it. Yeah, it's largely a Mumps program. Without getting into Mumps, which there are a handy set of videos if you want to look at them. The only place down there where it actually does it is right down. Here's one here. Okay, which is adds to the tree some values. Without explaining how Mumps works, this would be the reference would be the content of the reference. So the mesh blah blah blah, and the other part is the name that's stored there, like abdomen. This is abdomen. This is the indexed array version of it, and there's another one down here just like it, and that's it. They're virtually the same. The only one down here is it's postulating a third column, and the third column happens to be the length of the tree. the depth of the tree. Don't know why that's in there. It's, oh no, excuse me. It's in. That's part of Q subscript. I misread that. Eyes are going. Q subscript tree comes. What it does, it extracts out the ith value of the row in the mumps program, in the mumps array. So that's all mumps. It's not nothing to do with the. It happens to be the argument to a GTK function, but it's actually just plain old mumps parameters. First part of the GTK function is the name of the tree store. You kind of have to have that. And then the depth at which it's going in, how deep down in the tree, top level, second level, third level, and so on. And then the values. First one here is that mesh printout, up arrow mesh 1, comma 2, comma 3. And the next one is the name associated with it, like body regions, abdomen, abdominal cavity, so forth. And then finally here, this extracts out the last index in the mesh description, in the mesh reference. So anyway, there's only 2 lines of actual GTK in there. And as you've probably guessed, for most of the GTK commands or functions that I've incorporated, instead they have underscore. You can't use underscore in mumps because it means something else. So I use squiggle, and I actually like squiggle better. It's easier to type than going for the underscore all the time. At least it's easier for me. But anyway, so instead of underscores, I just use. And the $Z is a mumps-ism. Added functions in mumps begin with $Z. Okay, I know that's hopelessly confusing, and you're probably saying, what the hell's going on? But nonetheless, it had basically built your program. I mean, you have to go in there and do something. But, you're all set up, ready to go. I'm going to kill this. I guess I'll just say goodbye to that. I've got anything else up here. I haven't got Glade running anywhere, do I? Okay, that's the one in that. Let me go now to this directory. I'm in a different directory. This directory is much simpler. It has very few things in it, as you notice there. It's got some temporary files. These are temporary pointer files and so forth. But anyhow, I should have erased some of these which are unnecessary. Okay, mumps.glade. This is I'm going to do the example. Now, what have I got here? I've got a window and I've got a fixed. Window I cleverly named window. And fixed I cleverly named fixed 1. And the only thing I changed here is I went to the size, 703. I hate odd numbers. There's a good reason not to use odd numbers in some of these things, because many times internally they divide by 2 and you get an edgy result. I found out working with video that keep it even. Actually some things with FFmpeg and so forth, you've got to keep it even. If you don't, meteors will strike the earth or something. I don't know. But anyway, I even tends to not cause problems. Odd doesn't cause problems as a rule. But all right, so I got a blank slate there. That's nothing. That's a top-level window, okay, and a container top-level fixed 1 down here. They very cleverly not alphabetized these to hide them. I do not know why these are not alphabetized, but anyway, so I simply dragged a window in here. I created, just typed in Glade, okay? And then when I came up, I said, create a new window. It's this guy up here. Create a new project. I'm not going to do that. And I created something empty. And I went over here and, let's see, one of these here is, here, right down. When I click save, it came up with what name do you want to save it under, and that created it, Glade. And then I dragged in the window and dragged in the fixed. Okay, that's simple enough. We want to let's start off with the simplest thing possible, a button. Everybody wants a button. Big buttons, little buttons. Okay, see what I did? I'm right-clicking, obviously, to drag that. I dragged in a button. And I need to give it a name. I don't know, let's call it Fluffy. Button 1 is probably a better name. But anyway, called it that. And what do you want to put in the button? Okay, anything you want to type. Click me. There's some other things here, but the defaults are normally correct. You can go to here and change the size. If you default, it goes to, get rid of the default sizes, it goes to a minimum size, or you can make it a really giant big button by increasing or decreasing these numbers. Packing is where it's located. It's a little off center. There's my, because the way I dragged it, there, now it's kind of centered, doesn't matter. Then I go over here to signal. These are deprecated. They're telling you don't use them, but you can. You get warnings. Now I clicked in that and you see it open up, and I type on because all these signal handlers by default start with the word on. And it suggests one, on fluffy clicked. Okay, it's going to suggest the most obvious one. You're not done. This is where people make a mistake. They move to another window saying, I did it. No, you didn't. You didn't hit enter yet. Hit enter. I get so many emails saying, I did that, but it didn't work. I said, you probably didn't hit enter after you named the signal handler. So that's got a signal handler, on fluffy clicked. Okay, and it's a problem. It's not an error. Just have to remember that you want to hit enter and make sure you see it solidly. So this looks fine. It has to be called mumps.glade. The program is looking for mumps.glade. I just saved it. Now here, this is in that directory, and I'm going to run the same thing. Okay, and it regenerated it. There it is. Click me. Now, by default, it generates a file, a response file that says it's been clicked. Okay, I'm just clicking it. We're having fun. Now, what you want to do is that your problem at that point. So what happened over here, you see there is an on fluffy clicked down here. All right, that got built. And all it puts into it is, a stub saying, okay, it's been clicked. What do you want to do with it? Yeah, I mean, this is where you could read from a database, give answers, calculate stuff, give out the, well, let's say, let me just put quote, comma, $ZD, I think, gives me a full one exclamation point, and save it. Okay, since it's not compiled, since this thing is it running anywhere? No, I didn't run. I turned it off here. So now when I click it, at least over here, you'll see the day and time is Monday, January 17th, blah, blah, blah. So every time I click it, it'll do it. So it's running live in the background. And so you can add code to it and do things. Now, a button isn't one button by itself. It does not a program make, but it's the start of a program. And we'll try some other examples in the next couple of videos.